Have a look at October 2012 question 5. In the early part of the 4 o'clock to 8 o'clock watch over 100 0800 on the 10th of June, the OW obtained a bearing of Venus 077 degrees gyro. Got a DR position 10 degrees 30 south, 82 30 east. Chronometer showed 10 hours 53:22. It was slow. Find the error, the gyro. So the first thing we do, 10th of June, approximate time was 0600. We apply our longitude to that, so we find that the approximate GMT or UTC time 0030 on the 10th. Well, when we look at our chronometer, it showed 10 hours 53:22. So that's in effect 22 hours 53, because our approximate time is around midnight on the 10th. So the chronometer would read correctly as 22:53:22. Now, of course, we're now into the 9th. So once you apply the longitude, we're actually into the 9th with regards to GMT or UTC. 22:53:22. Apply the error, the 01 minute 11 seconds. So the time we're going to use is 22:54:33, because of course we need to use GMT to use the tables. So we would then go into our almanac under Venus and get the GHA. Don't forget at the bottom you've got the V correction that you need to use for GHA, and of course the D correction for declination. So we write down our GHA at 22 hours, go into the increments to get the 54:33, apply the V correction, and we can see that from the V correction we need to add that, and we get our GHA of Venus, apply the longitude, that gives us our LHA. So we've got our LHA, declination of Venus, we check to see how the D correction is applied. We see that declination is increasing in the book, so therefore it's added. So we've got our declination 10 degrees 13.5 north, LHA 292 20.6. Now we calculate A from our table, our formula sheet. We know it's tan over tan 10.5 over, which is tan declination over tan LHA, and B, we know that we've got there tan 0.225. Sorry, A is tan latitude, of course, over tan LHA. B is tan declination over sine LHA. So we get those off the formula sheet, we write them in, and we can work out our value of A and our value of B. Of course, B is always named the same as declination, and A in this instance is named opposite to latitude. If you're unsure how to name them, of course, look in the Norris tables, and that gives you a clue under the ABC values. So we've got A and B, and therefore C is going to be the two of them added together, because of course they're both north. So we get our value of C, 0.27118. Tan azimuth is 1 over 0.27118 times cosine of 10 degrees 0.5, which is our latitude. Therefore we get an azimuth of north 75.1 degrees east. Okay, and it's named east, of course, because of the LHA, but again the hint is in the Norris tables. So our true bearing was 075.1 that we've just obtained. Our gyro was 077, so in effect our gyro is reading 1.9 degrees high. These are very useful questions to get in the SQAs because they're reasonably straightforward, and in this instance, of course, it's worth 10 marks. Part B, state 5 instances when the OW should check the gyromagnetic error. Well, you'd need to check if you made any major alteration of course. You need to check if there's you've taken a compass error and it's quite a large error. You'd need to check the gyromagnetic compass then. If there's any, every watch at least, you need to change it. If you're going into areas of magnetic anomaly, you'd need to change it. And that would be the 5 instances. So that's how you'd answer that particular question.